Hello, everybody. I would like to share with you a project that I am working on. I'm trying to work on a method that will allow us to get better results even on low GPU VRAM using LCM tensors model and some methods associated with the multi-step inference process to have a best time generation. So, let me know if you prefer it generates vertical videos or you prefer to have the setting to change the size of output. And if we want to increase the length of the video from 8 seconds to 16 or make it longer. We also want to set up a set of tutorials concerning modeling, shading, and rigging on Blender for 3D conception. All this will allow us to go through the necessary actions for the implementation of stylish animations by mixing 3D with ComfyUI. I would build AI process for more style adding 3D, 2D animations with ComfyUI models painted, and projected to background creating an environments and objects in the foreground and midground. All your suggestions, help and support are welcome.
Don't forget to subscribe and hit the notification bell. So, let's go.
Let's start with a clean workflow. Make sure to install all the custom nodes. If it's not the case, go through Manager menu and install all custom nodes needed. All the resources are mentioned in the video description below. So let's go. We need KSampler, the efficient one. You can follow the path with me or by research method. We load a video upload. I hide the preview. So, we need a checkpoint to load the LCM model. Follow the menu path with me. I choose it with noise select. It is possible to use another model, and not the LCM one, but you have to be sure you have the right equipment for that. Then, we load VAE node. I try to mix between search and menu method to load the nodes to know them all. It is important to know that the VAE plays a very important role in the results of the final image, so make sure you choose the right one for your model. Then, we need to load a node for the positive prompt. I prefer to use the batch prompt schedule for this work. That's allow us to change the prompt wherever we want on the video generation. And then, I use a simple clit text encode for the negative prompt. That's all we need to start a normal work for video generation. So, of course we need an output to see the result. That's why we will load a video combine node via Video Helper Suite and tag a video format. After that, we need to connect all the nodes correctly, making sure we put the positive on the positive and negative on negative and thing like that. So, let's move to a second part. In this part, we want to control the size of the video. And for that we need an Upscale image node to connect with an empty latent image. And we need a VAE encode to connect that to the KSampler. There is one important thing that we want to do. That is to control the width and the height for the image. And for that I will use a two primitive. One for width and the other for height that we convert on an input in Upscale image and empty latent image node. After that, we connect the nodes. just do it like me. And if you need, you can pause the video. Then, for more better effect, I add a latent blend node shot we can control with factor. That's all now. So now, we move on to the animation phase with AnimateDiff. This method does not break the diversity of the original model. So, we load AnimateDiff legacy by following this menu path. And of course, the context option look uniform. So, for the animation, we need a LoRa node, because like we see in previous video, AnimateDiff can work with LoRa. I will use 2 LoRa's nodes for this work. I use one with rolling anti-clockwise, and the other with a zoom out. You can change it by a zoom in or any one you prefer. I don't change the strength for the moment. And for better result, I like to use free UV2 node. You can make very good animation variation with this node. So let's connect all these nodes. I keep it simple for better understanding. So just do it like me. Alright, now we want to transfer a subject or even just a style of the reference images to our generation. And for this, we will use IP-Adapter node. Make sure you have the last version. So, once I load the IP-Adapter embeds, I need to load the IP-Adapter combine embeds and also the encoder. So, if you want more information for the IP-Adapter Plus, you can go to my IP-Adapter V2 video. I put the link in the description. It's a very good source with beautiful workflow. But I will still explain briefly the process and nodes that we need for a good job. So, we need a model loader, or you can use the unified model loader. The legacy loaders work with any file name, but you have to select them manually like me. So, now, double-click in an empty place and search for Prep Image for Clip Vision node. Do the same for in Preview Image and Load Image. We gonna need this node to load the reference image we want. So, as a reminder, if you use the IP-Adapter Unified Loader, it will be loaded automatically if you follow the naming convention. Otherwise, you have to load them manually, Be careful, each model has to be paired with its own specific LoRa. Then, we have to connect correctly the node. You can pause the video if you need. In this work, we're gonna use 4 images for reference. So, we will have to do the same thing 3 times. So, I speed up the video playback for this step. Pause the video if you need, but make sure the connections are good. So, now that the connections are correct, let's move on to some parameter adjustments. By choosing the IP-Adapter model loader, I work with IP-Adapter plus SD15.bin. And let's see what the model checkpoint we have. I'll choose the LCM because it's faster. And for VAE, I choose 84,000. That's all. The resolution is okay. And for the prompt, I keep it very simple for the test. It's important to respect the prompt conditioning, so no comma in the end. So, let's take a look. Everything seems okay. Alright, let's connect the model to the IP-Adapter model. VE to VAE encode. And all the final adjustment, like the frame number to generate. And now a global look for the nodes. So, until here we can start generating with no problem. Now the hardest part is done. Let's get back to our goal. We want to generate a video from 4 reference images. We then need 3 other IP adapters. And for that, we will simply reproduce 3 times the nodes that we already have and connect them to IP-Adapter combine embeds. So I will speed up the video again and leave you make pause if you need. So let's go! So, I think everything is okay and quite clear. And now all we have to do is add the 4 reference images. You can use the images that suit you the most or that suit your own style. You will be able to get an idea after a few tests. The main thing is to understand the mechanism and the process, because we are going to develop the workflow during our next videos, and moreover, I am going to take advantage of this and add now a ControlNet node with a QR model after generating test. So, we right-click and search for efficiency nodes. And stackers. And ControlNet stackers. And now we need the QR model. So do like me. After that, we need to go to ControlNet preprocessors, the line extractors, and choose head soft edge lines. And convert the resolution on input. Make pause for the video if you need. Then connect the node size to it. So, we need now an apply ControlNet stack to connect the ControlNet to the case sample with prompt conditioning. And that's all. We can now keep prompt and have fun. In our next video, we will do some work to have multiple figures and many more choices for better videos. So see you soon!
Don't forget to subscribe and hit the notification bell. So, keep in touch.